All right, let's get right into it. Today we are tackling a big one, SAES-P-104. If you're in the electrical field and working with Saudi Aramco, this document is your Bible. Seriously, understanding it is everything. So, our goal today is to break it all down and get you ready. So, if you're an engineer, a designer, or a technician, and you've got your sights set on a roll with Aramco, or you're already on a project, you know this standard is looming. P-104 is more than just a document. It's the first major technical hurdle you have to clear. It's the benchmark they use.
And I really mean that. It's your first test. This isn't just some dusty rule book you put on a shelf. The stuff in here, it's the core of your technical interviews, and way more importantly, it's what keeps you doing safe, compliant work out in the field. Nailing this shows you mean business.
Okay, so here's our game plan. We're gonna treat this like a proper study session. First, we'll cover the foundation, the why. Then, we'll get into the building blocks, the core materials. After that, we'll look at the different arenas, above ground versus below. Then comes the really high-stakes stuff, safety and testing. And we'll wrap it all up with a final exam, how to absolutely ace that interview.
So, let's start at the beginning. Section 1, the foundation. What exactly is this standard, and why is it so important?
At its core, SAES-P-104 is the law. It lays out the mandatory rules for designing and installing all your power and control wiring. Think of it like the blueprint for the entire electrical nervous system of an Aramco facility. It's all about making sure everything is safe, reliable, and done the exact same way every single time.
And you gotta stay current, because this document changes. The February 2024 update had some huge ones you need to know about. For example, RTRC conduit is now allowed underground. If you're offshore, you're now required to use fiberglass trays with solid covers. Testing for high voltage cables got even stricter, and there are totally new rules for submarine cables. Knowing these latest changes is a huge advantage.
All right, next up, let's talk about the building blocks. These are the non-negotiable rules about materials that you have to have down cold before you even think about starting a project.
And here is rule number 1, and it is crystal clear. Copper is king. The standard says wires and cables shall have copper conductors. Full stop. Now, there is one very narrow exception. You can use aluminum, but, and this is a big but, only in non-industrial settings and only for bigger cables. If you mix this up in an interview, that's a huge red flag.
You're gonna wanna screenshot this slide. This table is pure gold for studying. These are the absolute rock-bottom minimum sizes for copper conductors based on voltage. You can see how the size jumps up as the voltage increases. I promise you, these numbers, especially the low voltage ones, come up all the time in those rapid-fire interview questions.
Knowing what to do is important, but knowing what not to do is just as critical. The standard is very clear on things you just can't use. Solder lugs for terminations? Nope, prohibited. Intermediate metal conduit or IMC? Not allowed. Using those little wraparound sticky labels for your wires? Not permitted. It's these details that really show you know your stuff.
All right, we know our materials. Now let's talk about where they go. Section 3 takes us to the two main battlegrounds for installation, above ground and below ground. And trust me, each one has its own unique rule book. So when you're working above ground, you're mostly dealing with ladder-type cable trays, and each rung needs to handle at least 90 kilos. Here's a tiny detail that interviewers love. For outdoor trays, your cable ties have to be nylon-coated 316 stainless steel. Then, when you go underground, it's all about depth and protection. The burial depths aren't suggestions, they're mandatory. And you have to put those red warning tiles exactly 300 millimeters above the cable. And this table from the standard shows you just how specific it gets. Look at this. A medium voltage cable, say up to 35 kV, needs 920 millimeters of cover if it's direct buried. But if that same cable is inside a conduit, the requirement drops to 610 millimeters. These are hard numbers, you just have to know them. Let's get into section 4, what I call the high stakes rules. This is the stuff that prevents catastrophic failures, keeps people safe, and gets the most attention during any kind of inspection or interview. Pay close attention here. 1.8 meters, memorize this number.
What is it? This is the absolute minimum distance you need between two separate parallel power lines that are feeding critical equipment. Why? It's simple. This spacing makes sure that one guy with a backhoe can't accidentally take out both your main power and your backup power in one go. It's a huge deal.
And it doesn't stop there. The standard is packed with other separation rules to stop electrical interference. You need 300 millimeters between a medium voltage and a low voltage cable. And if you have a really high voltage cable, anything over 33 kV, you need to keep it a full meter away from any lower voltage cables. These rules are just fundamental for a stable system.
So you've laid your brand new medium voltage cable. Great! Are you done? Not even close. You have to test it, and the sequence is everything. First, you run an insulation test before you bury it. Then you bury it, and you run the exact same test again. And only then do you do the final high voltage test, the high pod test. It's a step-by-step process to make sure that cable is perfect. Now this quote here points to one of the most critical safety concepts in the whole standard. You know those ceiling fittings people use to stop gas from traveling through a conduit? Well, in hazardous areas, you don't use them. Instead, the entire conduit has to run clean through the hazardous zone and pop out into open air on both sides. This simple design trick makes it impossible for dangerous gas to get trapped in your electrical system. It's brilliant.
Okay, you've been absorbing all the theory. Now it's time for the final exam. Let's put this knowledge to the test and get you ready to walk into that technical interview and just crush it.
All right, picture it. You're in the interview, the manager asks you this exact question. This is a fantastic question because the answer isn't just one thing. It tests if you can pull multiple rules together. So, what do you say? Here's how you deliver a killer answer. You break it down into this 4-point check. You say, first, the conduit itself has to be threaded, rigid steel that's been hot-dip galvanized. Second, it needs a factory-applied PVC coating, at least 40 mils thick. Third, if we cut any new threads on site, we have to coat them with zinc-rich paint. And fourth, all the fittings need the same level of protection. See, clean, structured, and shows you know it inside and out. Okay, here's another classic. This one's a numbers question. It's designed to see if you know the really specific rules for high-voltage terminations. So, what's the magic number you need to remember here? And the answer is actually really simple if you just know the rule. For any outdoor termination, the standard demands 40 millimeters of creepage distance for every kilovolt of power. So you just take 40, multiply it by the system voltage, 13.8 kilovolts, and boom, you get 552 millimeters. It's easy points in an interview if you're ready for it.
And we'll end on this thought. Look, it's great to master the rules in the book, but the real world, it's messy. You're going to run into problems that aren't perfectly described in any standard. The real test of a great engineer isn't just knowing the rules, but knowing how to think on your feet and apply them with good judgment when something unexpected comes up. That's the question that really separates the pros from everyone else.